Hello everyone, this is Ms.Somsubhra Saha. I work as an assistant professor in Veltech Multitech Dr. Rangarajan Dr. Shakuntala Engineering College in the Department of AIDS. Today's video lecture is on multivariate and time series analysis. This topic is one of the topic of the subject exploratory data analysis. So before moving into the multivariate and the time series, first we have to know what is third variable. Now suppose there are two variables in statistics, one is x and one is y. Now x is an independent variable and y is an dependent variable. Suppose there is another variable called z. Now this z is related to both x and y, and this this z is known as the third variable in data analysis. So as it is shown in the screen, the definition is a third variable in the context of data analysis refers to an additional variable introduced into the analysis of relationship between two other variables. Now these third variables are of two types. One is numerical, the other one is categorical. As per the name numerical, it can be already known that numerical means it's related to numbers. So basically data which is related to numbers are considered over here as numerical data, like age, income, temperature, etc. Next is the categorical data. Categorical data means groups or categories, that is discrete categories basically, like gender, male, female, region, whether it's a hilly region or it's a desert region, or educational level, literate or illiterate. Now, the use of this third variable is that it provides an additional insight into the relationship between variables. Now, this third variable can be incorporated in different techniques like visualization techniques, statistical summaries, advanced technique, correlation analysis. Now, visualization technique. Now, scatter plot is like, suppose there is xy axis there, and another xy variable is there in a plane, and another variable z is introduced into the plane. Now, to denote that particular z variable, we can use different colors or different size of data points, or maybe symbols also. For example, suppose for any dependent data point I am using the variable symbol plus, whereas for independent data point I am using the variable minus. Now another third variable came in between these two data points. Now for that third variable I am using some other sizes, shapes like circle or triangle, anything. So this is how in scatter plot the third variable is visualized. Now next is the facet grids or small multiples. Facet grids or small multiples, basically it is useful for categorical third variable only, where it shows a clear separate plots or levels of the third variable. Now 3D variable, 3D variable or 3D plots. 3D plots, it is used for numerical data. It shows how the interaction is between the three variables, uh, that is the interaction between the three continuous variables is shown through 3D scatter plot. Next is the heat map. In the heat map, the third variable, whether it's categorical or district number, it also shows the interaction between all the three variables. That is, the connection between all the three variables are also shown in heat maps. Next is the statistical summaries. Now, statistical summaries means that we have to compute the summaries. For example, in the first point, it is like pivot table or group by. Pivot table means for categorical third variables, some calculations like mean, median, mode, or variances, these are all computed with the help of this group by method or pivot table for each the group or combination of the first two variables. Next is the regression. Regression, it helps the model to the relationship of the model. Actually, it helps two variables, the relationship of the two variables uh, while considering the effect of the third variable also. That is, what is the effect of the third variable between these two variables. These are all measured with the help of the process called regression. Now, this regression can be introduced, can be useful to understand how the relationship changes based on the third variable. That is, what is the effect of the third variable on these two variables. That is, one dependent and another independent variable. Now, the next technique is advanced technique. Advanced technique, there is one point called contour plots. What happens when it is dealt with two continuous variable and one categorical or discrete variable? The measurement of the density, that is the how many times the third variable is occurring at different level, is being measured with the help of this contour plot. Now in the previous plot, we already know that what are the in the contour plot, we know that what are the different levels, how many times a third variable is occurring in different level. But in correlation analysis, the correlation helps to actually, in the correlation matrix with the third variable, we can compute the correlation for of the third variable separately for different levels. That is, uh, for example, if only it is a categorical data, then only we can compute the correlation for different level. Now, the correlation analysis also helps to identify that what are the changes happening between the correlationship when the third variable is the in the factor. That is, in between the two variables, when the third variable is putted, what is the effect between those in the correlation of those two variables due to the third variable. That is also we can understand, or we can identify with the help of this process called correlation analysis. Now next is the contingency table. Contingency table is nothing but a table where the frequency distribution of the variable is shown. Now it is very much common for categorical data rather than numerical data. Now whenever, suppose there is a table where two variables are already existed, x and y. Now I am putting another variable, for example x square or xy is another variable which is considered as third variable. Whenever a third variable is added to the contingency table, it becomes three variable contingency table. See, this is an example of three variable contingency table. Now, this x square, which is the experience, is not, if it is not there, if this column is not added to the other part of the table, then it is not considered as three variable contingency table. Since x square or x2, that is the experience column, is added over here. Now it is, there are three variables, that is, one is x1, another one is y, and the third variable over here is x2. So there is a three variable. Since there is three variables, so it is considered as three variable contingency table. Now how this third variable is affecting both x1 and y, that is the first two variable. In this example only, we can see that x1, which is the training column, the first is whether the training is happening or not, it is written. So the for the first row, the training is happening. How many students are performing good, that is the y variable. Now in the first, for the first point, that is the first row, the 50 students are performing good and 20 students are performing bad. So the total number of students is 70. Similarly, in the second row, 30 students has performed good and 40 students has performed bad. Over here also the total number is 70. Now see in the third column, that is the third variable column, how it is getting affected. Since the y first, for the first row the y is 50, that means the performance is good, so the experience is considered as high. Whereas in the second row where the y is 13 and whereas the poor performance is more than the good performance, so the experience is counted as low. So this is how the third variable is affecting both the first and the second variable. So now the next slide is causal explanation in third variable contingency table and beyond. Now what is the causal explanation? Causal explanation means cause and effect of the relationship between variables. That is, whenever a third variable is added between the two variables, what is the cause and what is the effect that happens in their relationship. This is called the causal explanation. Now whenever a third variable contingency table is being dealt, that is, whenever we work with a third variable contingency table, now in that case it is called the moderator or co-founder. Why moderator? Because of the third variable, the first two variable gets affected, or there is a particular influence on the relationship between the first two variables. That is why it is called moderator. Now next is that this third variable also helps to differentiate between the cause, that is the causation, and the correlationship. That is, it also gives more depth to the analysis, that is specific analysis. For example, in the previous slide, in the table we can see there are two variables x and y. X and y, they both have their data, but because of the third variable x2, because of the third variable x2, we can differentiate which, how specifically, which is high, which is low. So that is the correlationship and causation. That is how it can be analyzed in more depth. So the next slide is fundamentals of time series analysis. What is this time series analysis? Basically, it is a study where it shows that what is the behavior of the data points at specific interval of time. That is, the data points are collected and recorded at specific intervals over time. Now over here in this time series analysis, we can determine the trends, seasonal patterns, and temporal behavior of the data. Okay, and how we can also predict what will be the future values of the data from its movement. Now what are the components that affect this time series analysis? First one is trend. Trend is basically referred to the direction of the movement of the data points, that is with a specific time duration, how the data points is moving, whether it is going up or down or it is not moving at all. These are all analyzed in this under this component called trend. Next is seasonality. Seasonality means the regularity, whether the data is repeating itself or fluctuating and at a fixed time period. This is these are known as seasonality. Now the third is the cyclic pattern. Cyclic patterns mean suppose there is a long term of fluctuation. Now it's been analyzed whether this fluctuation is occurring in specific time period or not. This is called cyclic patterns. The fourth one is irregular or residual. In irregular or residual, what happens? Suppose there is some abnormal variations is being seen in the data point. So in that case, what happens? These all these analysis goes under these components called irregular or residual. Next is the stationarity. Stationarity means Even if in the time series, suppose there are data points whose properties like mean, medium, or variances, or standard deviation, they don't change over time. These are called stationarity. Now stationarity are of two types. First is strict stationarity, another one is weak stationarity. Strict stationarity, what happens? The joint distribution of the data remains the same at different time points. That is, the data don't changes according to the time points. This is called strict stationarity. Next is the weak stationarity. Weak stationarity means maybe the data is changing, but according to the time points, different time points, the data may be changing, but the mean and the variance of the data are constant. So this is called weak stationarity. Now the third point is autocorrelation and partial autocorrelation. Now correlation, we know it measures the correlation. Basically autocorrelation is a technique which measures the correlation, and correlation we already have seen what is this correlation. It measures the depth or the number of times the third variable is occurring and each and every different level. Now this correlation is measured by the process called autocorrelation, and this correlation, it measures the correlation between observation of a time series separated by a time lag. Now autocorrelation function, next is the autocorrelation function. What is this autocorrelation function? It measures how observation at different times are correlated with each other. So this ACF or autocorrelation function is very helpful for seasonality, cycles in the data, identifying patterns, etc. So next is the partial autocorrelation function, PACF. Now it measures the correlation between time series and its lagged values, controlling for the values of shorter lags. That is, for the short time period, how this correlation is measured. The measurement of the correlation for shorter lag, it is called partial autocorrelation function. Okay, next is the smoothing technique. Smoothing techniques, the word smoothing, from the word smoothing itself, we understand this that it's removal of some irrelative data or irrelative pattern, that is removing of noise. This is called smoothing technique. Okay, now for those things, the first thing is for calculation is moving average, that is MA. What is this? It is the average. It takes basically the average of the data point for a specific window to smooth out short-term fluctuation. So MA is used to remove short-term fluctuation. Next is exponential smoothing. Exponential smoothing is that weights past data with exponentially decreasing influence on future forecasts. That is, suppose in case of stock market or anything, suppose the data are exponentially decreasing. Now when the data exponentially decreases, it obviously have some effect on the future forecasted. So that is how things are removed over here. Next is simple exponential smoothing. It basically related to the movement of the data or seasonality of the data. That is, if the data is useful without its trend or seasonality, that is without its movement, whether it is moving upward, downward, or according to the season it is moving, if it is not considered, then how the data is being used, this is called simple exponential smoothing. Next is Hall's linear trend model. In Hall's linear trend model, what happened? It extends exponential smoothing to capture trends. So it uses one of its own technique to capture the movement of the data. Next is the Hall's Winters model. Its Hall's Winter models is also same. The first one is for capturing the movement and second one is capturing the trend. So this is the last slide of the time series component, that is the decomposition of time series. Now time series decomposition means breaking the time into different basic components like trend, seasonality, residual or noise, whatever. And next is the Additive means if we add both trend, seasonality and noise or residual, then it is called additive. It is also equal to time series. And multiplicative is trend. If we multiply these three components like trend, seasonality, residual, then it is called multiplicative. So okay, so the next we will move to the characteristics of time series data. Now there are different characteristics of time series data as we can see in this slide. First is the temporal ordering, then time intervals, trend, seasonality, autocorrelation, noise or residual. Each and every point has been discussed very properly into the given slide very properly. I hope you understand everything. If there is any query or anything, you can reach to us through the comment section and anything. Best of luck for your study. Thank you.